Let's practice graphing using transformation of functions. So we have some basic functions here on the left. These are functions that you should memorize. You need to know what graph goes with what type of equation. So when we look at an example like this one, f of x equals x minus 4 cubed plus 2, we can look at this and recognize right away that that cubed tells us what shape this is. It tells us that this is a cubic. And the cubic shape is the shape that looks like y equals x cubed. Next, the other elements of this equation also tell us what we're supposed to do. Remember, you should read this equation not as algebra, not as work that needs to be done, but as directions on how to draw your graph. So that plus 2 is telling us to shift up. And that minus 4 inside the parentheses, inside the grouping symbol, is telling us about a horizontal shift, a shift to the left or to the right. But we do want to keep in mind that inside the grouping symbol, it's backwards of what you might expect. So that negative actually means to shift or translate to the right. Now that we have our directions, all that's left to do is to draw the graph. Again, we haven't done any calculations. We haven't computed anything. We just read what it said, and we're going to do what it says. 1, 2, 3, 4, 5, 6, 7, x, y. You'll notice I label my axes as x and y. That's important. Don't make the person reading your graph assume that that's x and y. While in algebra, most of the time your graphs are x and y, outside of a pure algebra or pure calculus or pure mathematics setting, very likely those are not x and y. Often the horizontal axis is t for time. Often the vertical axis might be p for population. It might be h for height. It may be a for altitude. It could be v for volume. It could be P for profit. I don't know what that axis represents. So I have to always tell people. Similarly, I have to tell people what I'm counting by. Now I'm counting by ones in this graph, and that's why you see that I've put tick marks at every one, and I've labeled that so that you can see we're counting by ones. And we often do that in these pure math classes because we have nice graphs with nice numbers to work with. But in real life, most applications outside of math aren't going to be counting by ones. They might be counting by millions or by 50s or by 37s or whatever is a convenient number. So always, always, always need to label that as well. So our graph is going to be shifted 4 to the right, 1, 2, 3, 4, and 2 up, 1, 2. This is our new starting point. Now this graph, from the starting point, we would normally go up 1 and right 1. And then we would go down 1 and left 1. So from our starting point, I'm going to go up 1 and right 1, and down 1 and left 1, and then just draw our basic shape from there. And that's it. That is f of x. Let's try another example. Let's go ahead and graph g of x equals 4 square root negative x plus 1. So this time we have that square root symbol. That square root symbol tells us that the shape is half of a sideways parabola, you might say. In fact, it's this shape right here. Another way to remember that is to look at this shape and say, oh, if I kind of squint at that square root sign, it sort of looks like this. And I know I'm stretching it a little, but again, looking for ways to help you remember these shapes that you need to know. Also here, once we know the shape, we see that there is a plus 1. Plus 1, of course, means to shift up 1. Outside we have a 4. This is a vertical stretch factor. It's a stretch because it's bigger than 1, but we don't have to worry about that. It's going to tell us what to do. And finally, inside, we have a negative sign. And that negative sign means that this is backwards. Now that's not a technical math term, it's not backwards, but it is backwards from our basic graph. So here we are, we're ready to graph this one. Now again, I'm going to take the time to label the axes, x and y, and I'm going to take the time to label the scale on each axis. I'm going to count by ones again. Okay, so I'm going to shift up 1, and that's our only shifting, so that tells us where to start this particular graph. We're going to start it up here, shift it up 1. Now, this graph, we would normally go over 1 and right 1 from there, but two things are happening. One is we're going to go backwards, so instead of going right 1 and up 1, we're going to go left 1 and up 1, except it's not going to be up 1. It's going to be left 1 and up 4 because that vertical stretch is 4. So we're going to go left 1 and up 1, 2, 3, 4. And then draw that basic shape. And that's g of x. Next, let's do a third example. And in this third example, we're going to look at h of x equals absolute to x minus 2 minus 1. Now you might look at this and think, well, let's start with what we know. We'll start with the shape. The shape, this is absolute values, that's a V shape. Absolute value is a V shape. V for value. That's one way to remember it. Another way to remember it is if I tried to make that absolute value symbol with my fingers, it would look something like this, a V shape. Now I know you could really use two fingers and look like that, but if I tried to use them on the same hand, it would wind up making a V shape when I tried to make vertical, and that's our shape. And also looking at this, you can see the minus 1, and that clearly is telling us we're going to shift down 1. But here's where it gets interesting. As I look inside the parenthesis, or inside the grouping symbol, you might think that that's telling us to shift right 2. But it's not. And it's not telling us to shift right 2 because if I simplify this, if I factor this, this is absolute value 2 x minus 1 minus 1. So that we're really being told, yeah, that's telling us to shift down. Yeah, that's telling us it's a V shape, but it's really telling us to shift right 1. And then the 2 that's on the inside of the grouping symbol is telling us that instead of shifting, instead of drawing this to the right, stretching, we're going to compress horizontally. That means we're going to divide by 2. Okay, so let's draw this graph. This is going to be our last graph in this segment. So we are going to be looking at this, x, y, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 5. And drawing this graph, again, we are shifting right 1 and down 1. That has us right here. This is our V shape, but instead of going up 1 and 1 in either direction, up 1 and 1/2 in either direction. So here we are going up 1 and 1/2 to the right, up 1 and 1/2 to the left, and drawing the V shape through those 3 points. Now this isn't the only way to draw this graph, and this is one of the reasons I wanted to use absolute value here, because you might have noticed that we could factor that 2 out. And if we factored that through the absolute value sign, it would become a vertical stretch factor, and it would tell us to go up 2 and 1 in either direction. And sure enough, that would be the same graph. So this can be done more than one way. But the key to all of these graphs, and the way that you need to be doing all of these graphs, is by reading them as directions, telling you where to go, and drawing those basic shapes.